All right, guys, welcome back. Hope you had a nice break from math. It's been, like 8 days? So you hopefully had a really good break from math. But we're going to jump right back into it. Today we're talking about section 4.4 out of the textbook, and it's called Completing the Square. Before we get into what that means, just a quick review. It's been a minute. We've been in chapter 4 and chapter 3. We've mostly been studying quadratic equations. You're getting pretty good at working with them. We know it's a quadratic equation because it has an x squared, right? Or maybe it's not an equation, maybe it's a quadratic expression. But we know it's a quadratic because it has that square. Because it has that square, we learned in chapter 3 that we can graph this object. We can graph this function, this expression, and when we do, we get a parabola. I better spell that for you because you probably forgot. Parabola. Sometimes our parabola is upside down, but it's still a parabola. It just depends on what the numbers are doing. We learned in chapter 3 that I can draw this picture. Sometimes it's looking like this, sometimes it's going down, but we learned how to graph that. In chapter 4, we've kind of focused on these points right here. We've kind of focused on where the parabola crosses the x-axis, and we called those points the roots, or we called those the zeros, or we called those the solutions to the equation. All of those names mean the same thing. And that's kind of what we focused on in chapter 4 so far, is where does this parabola cross the x-axis? And you've learned all sorts of methods to do that. We graphed to do that. We also learned the quadratic formula, that great big beast. Remember, that was the x equals negative b plus or minus blah, 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 great big formula. You also learned how to factor a quadratic formula with the big X method and solve it that way. You also learned that if there's only one x, you can just take the square root and use that method and railroad tracks to get an answer. You also learned that sometimes there are no solutions, right? Sometimes the parabola never crosses the x-axis, and you end up with, it's still a parabola, it still exists, but it doesn't cross the x-axis, so we've said that it doesn't have any solutions, all right? So, chapter 3, we focused on drawing the picture. Chapter 4, we've really focused on finding the solutions to the equation. 4.4, the biggest benefit to section 4.4, in my point of view, is none of those things. 4.4 helps us find something different. 4.4 helps us find this point or this point right here. It's going to help us find the minimum value or the maximum value of our function. It's not going to help us find the zeros. Well, technically it could, but we have already learned lots of methods to find the zeros. You don't need one more. But what it can do is help me find the minimum or a maximum, which in the real world, when you're doing math, minimums and maximums are usually pretty significant numbers to know, right? You might want to know what's the maximum amount of product you can produce and still make a profit. You might want to know what's the minimum amount of products you can produce. You might want to know what's the smallest box or the largest box you can make with a certain amount of material. You might want to know what's the maximum square footage you can get using this material when you're building a house. There's all of these situations where you want to know what the maximum or the minimum is. You don't really care about the zeros. Sometimes you do, but there's other situations where you care about the maximum and the minimum. So we're going to use this method called completing the square to find the maximum and the minimum, all right? Now, I'll be upfront. The completing the square has kind of a bad rap. A lot of people, when they learned completing the square, this is what they learned. They learned, here's a whole bunch of steps, and you need to memorize them and remember them, and you need to follow these steps. And when you look at those steps, there's a lot of algebra going on. Subtract. So step 1, we've got to do railroad tracks. Step 2, we have to find the coefficient in front of the x value. We have to cut it in half. Then we have to square it. Then we have to add it to both sides. And that's the easy part. After that, we have to factor and solve with railroad tracks. There's all of these steps algebraically that go into completing the square. And I don't expect you to memorize all of those things. In fact, we're going to try really hard to not have to memorize much of anything when we're completing the square. We're going to approach this a little bit more like an elementary kid than a high school student. We're going to simplify all of these 5 steps, and we're going to focus on what does it mean to complete the square. All right, that's kind of if it's asking me to complete a square, I don't think about algebra. I don't think about dividing and square rooting and multiplying. When I hear, I want you to complete the square, in my head, I picture a square, and maybe it's not complete. If it wants me to complete the square, maybe it doesn't have, it's missing a piece, right? Maybe there's something missing from that square and I need to add it. Or maybe I have a square with too much stuff on it. Maybe my square, instead of being a square, maybe I have a shape that's bigger than a square and I want to turn it into a square. So when I hear completing the square, my point is I think geometrically. I don't think about algebra. I think about geometry. And so that's how we're going to approach these problems. We're going to focus on approaching these algebraic problems geometrically, all right? And some of you are going to love this. Some of you like geometry. You're pretty good at working with geometry. It's kind of like having a picture book. Instead of just trying to read a novel, you've got these pictures that go along to help tell the story. And that's what geometry does for math. I'm going to take these numbers and this algebra, and I want to make a picture out of it to help me solve the problem. So here's how we do this. If I have x squared plus 2x, and it tells me to complete the square. So my instructions say complete the square. Well, first of all, I don't see a square. I see a bunch of numbers. So what I want to do is I want to take those numbers and I want to build a geometric shape. I want to build a square out of those numbers. And it's not that hard to do because x squared, well, listen to what I just said. X squared is a really easy geometric shape to make because x squared is just a square and my sides are x long. That's all x squared means, is a square that's x by x, right? Because if I were looking for like the area of this square, I would do x times x and I would say, oh, that's x squared. So that's a really easy geometric shape to make. The other geometric shape I need to do, because I'm not just working with x squared, I want to add another shape. I want to add 2 times x. And if I turn that into a geometric shape, 2 times x sounds like a rectangle that's 2 wide and x tall, right? Isn't 2 times x 2x? So here's what I have to work with. I have a square, great. I also have a rectangle, and I'm trying to add these 2 shapes together. And when it says to complete the square, that's what it wants you to do. It wants you to take these 2 shapes, combine them, and to form a new square. All right, now here's how we do it. It's a lot easier than it sounds. I already have a square to start with, right? I've got this square that's x by x. That's this right here. That's this right here. And that gives me this shape right here. So now I've got to add this rectangle to it. But I don't want a rectangle. I want to keep this a square. And so the way that I'm going to add my rectangle is if I look at my rectangle, it's 2 wide and it's x tall. If I just take that rectangle and I put it over here on the side, I can do that because it's x tall. It's the same height as this square, right? They're all the same heights. But it's 2 wide. And when I look at my big shape, it's no longer a square. Now it's a rectangle. So instead of just taking this rectangle, this 2x rectangle, and putting it next to my beautiful square, I'm going to take my 2x rectangle and I'm going to cut it in half. Instead of a 2x rectangle, I'm going to make it 2 different rectangles. They're both still x tall, but I cut it in half. So instead of being 2 wide, my little rectangles are now only 1 wide. All right? So the reason I want to do that is I'm going to put one of those rectangles right here, and I'm going to put one of those rectangles at the bottom. And I want to do that because now I feel like I'm closer to having a square. It's not this wide rectangle. Now it looks a little bit more like a square. So when I look at the shapes, my new shape, this length right here, now I've got this 1 because that little rectangle's 1 wide. This rectangle's 1 wide. Now the problem with my square is, I almost have this perfect square, but I'm missing this corner right here. So I took the numbers it gave me, and with those numbers, I can't make a square. I'm missing this beautiful corner right here. If I could find something to plug into that corner, then I would have a completed square. So here's what I'm going to do. I'm going to just add in a square. I'm just going to draw one there. Maybe let's use the same color. It wasn't there before. I'm going to add it there because now I have this beautiful square, which is what I wanted. I wanted to complete the square. Now this little square that I added, it wasn't there before. Let's see, how wide is it? It's 1 wide, and that square is 1 tall. So I added this square that's about the size 1, but I wasn't supposed to. I can't just add a square because when I add a square, it changes the equation, right? That square wasn't there before. I added it. So all I'm going to do is over here on the side, I'm going to minus that square. Since I added that square, I'm going to minus it because if I add it and subtract it, now I'm balanced out, right? So I've got this beautiful square. And if I look at that square, if I look at the length going across the top, if I want to look at the measurements of this square, instead of looking at the pieces that I put together, if I want to take this square that I put together and I just want to look at the entire square. So I want to look at this great big square, this beautiful, wonderful square that I made. These tell me how big it is. It is x plus 1 wide, and my square is x plus 1 tall. So my new equation is x plus 1 times x plus 1. It's just my square. But remember how I added that piece? Now I have to subtract it, which is super easy. Minus 1. Ta-da! You completed the square. You added a little piece to make it a beautiful square, and now you're going to subtract that away. So I've got x plus 1 times x plus 1 minus 1 is my new equation. And the reason we love that is I can rewrite that like this. X plus 1 squared, because x plus 1 times x plus 1 is just x plus 1 squared minus 1. And when I look at that, I see a graph. Because in chapter 3, you learned that this number and this number tell you about the graph. It tells you that I have a parabola, right? This square tells me that I have a parabola. This plus 1 tells me that I need to shift my parabola to the left 1. And this minus 1 tells me that I have to shift my parabola down 1, which means my parabola is going to start right there. And it's going to go up. It's going to be a parabola. But now I know my minimum. My minimum is negative 1. That's the lowest point of my parabola. So I can use completing the square to find a minimum. Now, I know that was a very abstract, wow, that was a lot of stuff. So let's go through a couple of these without all the fluff, okay? Let's just complete the square. So going through the steps that we went through, I've got x squared plus 6x, and it wants me to complete the square. So I'm going to start with my square, x, right? This is now this. Now I need to take this 6x's and I'm going to add it to my picture. And I'm going to do that by adding some of those x's right here and some of those x's right here. So I'm going to add 3 of them to the side and 3 of them to the bottom. So this right here comes from the 6x. Now I'm missing, I almost have a completed square, but I'm missing this corner right here. So I need to add something that wasn't there before. And that little piece that I'm going to add, if I look at how big it needs to be 3 wide, 3 tall, which means this little piece is going to have the size of 9. And if I'm going to add that little piece, I also have to minus that little piece later. So cool. Now I can rewrite my equation. Instead of x squared plus 6x, I can take this right here and this right here and write it x plus 3, x plus 3. And then I've got this stupid minus 9. It doesn't always completely go away, and that's all right because it's going to help me with my graph. X plus 3 times x plus 3, when we clean that up, I get x plus 3 squared minus 9, which is great because now I know, looking at this equation, I know that I'm going to be shifted left 3 and I'm going to be shifted down 9. So I can already tell you right now that my minimum is 9. That's the lowest that my parabola is going to go. All right. B, x squared minus 4x. Now, sometimes you guys see minuses and negatives and it freaks you out a little bit, but we're going to do the same thing. I'm going to take these two parts and I'm going to make them into geometric shapes. So x squared, that's just my regular x by x. That's my x squared, x square, right? The minus 4x, I want to do the same thing. I want to add, this is weird because technically we're taking it away, but I'm going to take that minus 4x and I'm going to turn it into -2 length rectangles. I took the -4, I cut it in half, so I get a -2 and a -2. Oh, maybe I should put that negative in front. So I still cut -4 in half, and I almost have a completed square. It's not quite complete yet. I need this box right here. Now, when I look at -2 times -2, that gives me 4. So this little piece that I added, -2 times -2 is positive 4, which means I have to minus that same square. I added 4, so now I got a -4. And since my square is completed, I'm going to, and I know I cheated a little bit, right? I completed the square. I made this beautiful square, but it has this little extra stuff. I'm okay with that because I have this nice looking square. So when I write that, I've got x minus 2 from right here, and then I get another x minus 2 from the side of the square. And because I added that 4, I've got a -4. So my final answer is x minus 2 squared minus 4, which tells me something. My graph is going to go to the right 2 and down 4, which means my lowest point on the graph is going to be 4. All right, I want you to try a couple on your own. So numbers 1, 2, and 3, go ahead, pause the video, and I want you to try answering those ones by yourself. Try really quick to complete that square. All right, so for number 1, you should have started with an x by x square, and then that 10x you split up. You put 5 of those x's there, and you put the other 5 of the x's going down, and to complete the square, you had to, wow, that is such bad language. You had to add this new square, which, if I look at my measurements, 5 times 5, that new square is 25, which means I have to subtract 25. So my square, this big one right here, is x plus 5 tall, and it's x plus 5 wide, and then I have to minus that 25 square that I added. So I get x plus 5 squared minus 25. Okay, for number 2, you started with your big X square, and then the minus 4, we did minus 2 right here, minus 2 right here, which means this square that we added has an area of 4, so that means I have to minus an area of 4. Is that the one that we already did? Oh man, I gave you the same one. Maybe you didn't even notice. Maybe you didn't realize, oh, I've already done this problem, and you did it by yourself. Good job, maybe, or bad job not recognizing we already did this problem. Okay, number 3, x squared. I start with that big X. Now the 7 x's, some of you might have gotten a little bit nervous. I still do the same thing. I'm going to add half of those x's over here and half of those x's at the bottom. So half of 7 is 3.5. So those are going to be 3.5, which means I've got this square that I need to add to finish my big square. So 3.5 times 3.5, yuck, what is that, 12.25? But since I added a square, I've got to minus that square. I wish I could just add squares whenever I wanted, but I have to if I add it, I also have to get rid of it, right? So my big square minus my little square becomes x plus 3.5 times x plus 3.5 minus 12.25, so I get x plus 3.5 squared minus 12.25. And done. That was an awful check mark. That one's better. Okay. Again, you can use completing the square to solve equations. You're going to see that show up. It's going to say solve this equation by completing the square. Please don't do that. We've taught you so many ways to solve equations. Graph, quadratic formula, big X, square root method. Use one of the methods you already know to solve an equation. Don't add a new one to it. That's silly. What we want to do is use completing the square to find minimums and maximums. So I've got this equation, x squared plus 4x minus 1. This is a little bit new because now before I just had a 4x, I didn't have this minus 1. But I'm looking for the minimum. So what I'm going to start with is I'm going to take this x squared plus 4x, and I'm going to complete the square. I'm going to ignore this minus 1 for just a minute, okay? I'm going to focus on the x squared plus 4x. So if I use completing the square to deal with the x squared plus 4x, I've got this square that's x by x. The 4x, I'm going to split in half. I'm going to put half of the x's down there and the other half right here. So to complete the square, this little square has an area of 4, which means I have to minus that as well. So when I rewrite this blue part, now remember, all of this that I'm doing is just that blue part, okay? I've still got that minus 1 floating out there. So I've got x, whoa, come on, pen, where are you? I've got x plus 2 times x plus 2. And then I've got my minus 4. But I also had this minus 1. And a lot of times you guys will forget, oh, but there's also this minus 1, that little square over there that I ignored for a while. So x plus 2 squared minus 5 becomes my new y equals. And I love that because now I know what that looks like. I know that this plus 2 means I'm shifted to the left 2, and this minus 5 means that I'm shifted down 5. So my picture goes left 2 and down 1, 2, 3, 4, 5, and it's going to go up. But what I care about is right there. My minimum value, my minimum is negative 5. God, we like that problem. Really cool use of completing the square. In fact, probably the only use of completing the square. Please don't use it for any other reason, all right? Let's use completing the square to find the maximum, which is the same as finding the minimum. The only difference is I have a negative in front of the x squared. That's how I know that there's a maximum. If that was a positive x squared, then I know my parabola would look like this, so I would have a minimum. If I have a negative x squared, my parabola is upside down, which means instead of a minimum, I'm going to have a maximum. All right? So here's how there's so many different ways to do this. Here's how I deal with the negative. All right? I change it. I take that negative x squared and I change it to be a positive x squared. And I take that positive 2x and I change it to be a negative 2x. And I take that plus 7 and I change it to be a minus 7. That's how I deal with the negative, and we'll fix that later, okay? I just get rid of it. I change everything to be a positive. And then I'm going to follow my same steps. I want to use this piece and I want to complete a square. So I start with the x by x, and then I take that negative 2x and I'm going to put half of those over here, and the other half I'm going to put down at the bottom. So I've got this weird little box that I need to fill in to complete the square. So that box is -1 by -1. So that box just has a size of +1. Well, I can't just add a box. I have to minus the same box to keep things balanced. So I'm going to minus a 1. And now I can write my equation. X minus 1 times x minus 1. And then I've got the minus 1 right here. And I also have a minus 7 from the very beginning. So when I rewrite this, I get x minus 1 squared minus 8. Now I'm not quite done, because when I look at this picture, I see a parabola going up. But if I look back at the original equation, my parabola should be going down, but I changed the negatives at the beginning. So I need to fix that. And the way that I fix that is, right now I've got this, y equals x minus 1 squared minus 8. I need to make that minus 8 a plus 8. The x minus 1 on the inside doesn't need to change, but I do need to put a negative on the outside of it. Okay? I don't want to put the negative on the inside, because when I square things, it just changes positives and negatives. So I want to put the negative on the outside instead. So my answer, my solution, my equation is rewritten as y equals negative x minus 1 squared plus 8. So now I can find my maximum, because this minus 1 tells me that I go, nope, not down. Wow, bad math, Mr. Reed. That minus 1 tells me that I go to the right 1. The plus 8 tells me that I go up 8. And that negative tells me that I'm upside down. So when I draw my picture, which I don't make you do today, I go to the right 1 and I go up 1, 2, 3, 4, 5, 6, 7, 8. So my picture looks something like this. And I only care about this part right here, because my maximum is positive 8. All right, your turn. 7, 8, and example number 9. I want you to try those on your own. Pause the video, try those on your own. Number 9, the only difference is the 2 is on the wrong side, so you're going to have to move that over here to start with, which you guys have gotten pretty good at doing that. So pause the video, try 7, 8, and 9, and hit play when you're done. Okay, number 7, you start by dealing with that negative, and by deal with it, I mean just get rid of it. X squared plus 4x minus 4. Now I'm going to use these two numbers to complete the square. So I've got x by x, and then that plus 4x, 2 of them are going to go there, 2 of them are going to go here, and to complete the square, that means I have to add this little square 4. But if I add 4, I also have to minus a little square of the size 4. So when I rewrite this, I get x plus 2 times x plus 2, and then I'm going to minus 4 from right there, but I also have this minus 4 at the top. So I'm going to minus 4 for that piece too. So I end up with x plus 2 squared minus 8. But at the beginning, I had this negative sign that I ignored and changed. So my answer needs to be negative x plus 2 squared and plus 8. I need to change those signs. So that's what my equation looks like when I rewrite it after completing the square, which tells me that I'm going to go left 2 and I'm going to go up 8. So that means I'm going to have a maximum of 8. And I know it's a maximum because this negative tells me that I'm going to be upside down. So that 8 represents the maximum. Okay, number 8. X squared plus 12x plus 40. I don't need to change anything. I can just take this x squared plus 12x and I can complete the square. So that means I've got an x by x. That 12x I'm going to split up and put 6 of them there, 6 of them there, which means to complete the square, I've got this little square of size 36. But if I add 36, I have to minus 36. So my equation becomes x plus 6 times x plus 6 minus 36. And I had this 40 at the beginning, so I have to add 40. So y equals x plus 6 squared plus 4. So that tells me that I'm going to go left 6 and I'm going to go up 4. So my parabola looks like this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. That's where my vertex is. So I have a minimum of 4. Okay, x squared minus 2x equals 2. I want to move that 2 over. So x squared minus 2x minus 2. So to complete the square, I'm going to focus on this part. So I've got a big square that's x by x. That minus 2 is going to become 2 little rectangles, and I'm going to cut them in half. So -1 and -1. And then this box, to complete the square, is size 1, because -1 times -1 is +1. But since I added that little box, I have to minus that little box as well. So my equation becomes x minus 1 times x minus 1, and then I have to minus that 1 that I added earlier, and then I have to minus 2. So I get x minus 1 squared minus 3. So minus 1 tells me that I go to the right 1. Minus 3 tells me that I go down 3. So I have a minimum of -3. Cool, your turn. Homework. I need you to do numbers 11 through 16, all of them. 17 through 22, the instructions say to find the minimum. In the book, it does not tell you to find the minimum. It tells you to solve. I don't want you to solve. I want you to find the minimum value, all right? And then 37 through 44, you need to do those as well. Those ones want you to write the function in that vertex form that we've been using, and then match it for the first 4, and the second 4 want you to find the minimum or the maximum depending on the problem. So use the examples from your notes and come see me if you have any questions.